Alright, so suppose you have weights on a balance. Each disc weighs 1 pound, and they're represented here in red and over there. So we have two discs and an unknown weight on one side, and this unknown weight is just an object that we don't know the weight of, and 5 discs on the other side, and the scale is balanced. Now balances show if different objects weigh the same amount. So if one object weighs more than the other, then the scale will be tilted with the heavier side lower. But if both sides weigh the same amount, then the scale will not be tilted and the bar will be horizontal, as is the case here. So this scale is balanced. So what we're trying to do here is find the weight of this unknown weight here. So how are we going to go about doing that? Now I know most of you guys could figure this out pretty easily just in your head, but let's just play along. So you're smart, so you know that you need to get the unknown weight alone on one side with the scale balanced and count the weights on the other side. So that would work because when a scale is balanced, that means that the weights on both sides are the same, they're equal. So if you have the scale balanced and this weight, this pink weight just alone by itself, that means however much is on this one side is going to be the same amount that is on this side, and that's going to give us the weight of that pink weight. So what you're going to do is try to get the this pink weight alone by itself. So you're going to take off these two weights here, and so this is what you're going to see. So now you've got the unknown weight alone on one side, but the scale isn't balanced. There's too much weight on the right side, and that's because we took off weight on the left side, but didn't take off any weight on the right side. So the right side's now heavier than the left side. So what we're going to do now is try to get the scale balanced. So to do that, we're just going to take off disc off the right side one by one. So you take off this disc, and still too much weight on the right side. Then you take off this disc, and it looks like it's going to be balanced. And this is what you're going to see. So now you've got the unknown weight alone on one side and the scale is balanced. So now you can count the weight on the other side to find how much the unknown weight weighs. So there's 3 1-pound discs on the right side. So that means this unknown weight is known to be 3 pounds. So that's pretty cool, but let's say you want to find the weight of a different weight, but faster and without having to take off the weights one by one. So this is set up here. So you've got 3 1-pound discs on the left side with an unknown weight, a different weight. That's why I put it in blue. And then that's 7 1-pound discs on the right side. So you think that since the scale is in balance, you should take 3 pounds off from the left side to get the unknown weight alone, but then also take 3 pounds off from the right side to keep the scale in balance. So your thought is, okay, I need to take 3 pounds off here to get this weight alone, but then I also need to take off 3 pounds here, because if I just took off 3 pounds from the left side, I already saw what's going to happen. It's going to be tilted. It's not going to be in balance. So your thinking is, if I take off a certain weight from the left side, 3 pounds, I should have to take off the same weight from the right side to keep it scale balanced. And so that's what you do there. You take off 3 discs from each side, and this is what you're going to see. It turns out that you're right. So you've got the weight alone on the left side, and the scales do balance, and so you find the weight of the unknown weight to be 1, 2, 3, 4 pounds. So whether you know it or not, you have solved an algebraic equation. You solved x plus 3 equals 7, and you found x equal to 4. So I hope you guys can see that the x plus 3 comes from here, where this x represented a variable to represent this unknown weight. Then we add 3 disc over here. We added those together to get x plus 3 on the left side, and then we had 7 on the right side, and this scale being balanced was the equal sign that says these two weights are the same. Okay, and let me also show you that if you were someone who just figured this out instantly in your head, you probably said something like 3 plus what is going to give me 7. And then you probably didn't consciously think of this, but you said 3 plus question mark, which you can think of as a variable just like x. Then you subtracted 3 from there, and then you also subtracted 3 from there. And what happens here is this positive 3, that's a positive, and this negative 3 cancel. Positive 3 minus 3 is going to give us 0, so that just crosses out. So it gives us question mark equals 7 minus 3 is 4. So that's kind of what we did here. If you can see the connection between the physical example with the scale or balance, we had 3 plus question mark, the unknown weight, and then we took off 3. We subtracted 3 from both sides, or we took off 3 pounds. We took off those 3 pounds on each side of the equation or each side of the scale. Okay. But the important thing to notice is that the operation we performed on the left side of the equation, we subtracted 3, we had to perform the same operation on the other side of the equation to keep the equality or the scales balanced. Now, I have a little club that I'm the founder of, and I like you to become a member. It's called Equations Club. And the first rule of Equations Club is what you do to one side of an equation, you must do to the other side. And the second rule is what you do to one side of an equation, you must do to the other side. Always. Now this is an intuitive concept with a scale, right? If you add more to one side, you have to add the same amount to the other side. If you take away some from one side, you have to take away the same amount from the other side. You have to do this to keep the sides balanced, or with an equation equal. And we can express this with a mathematical property I've got down here called the addition property of equality. And it says if a, b, and c are real numbers, then a equals b and a plus c equals b plus c are equivalent equations. Now this might be a little more formal and mathy than you guys like, but all this is saying is that we can add anything to one side of an equation. As long as we add the same amount to the other side, the equations are equivalent and the value of the unknown variable does not change. So we just added c to both sides, and this gave us an equivalent equation to this. Of course, since subtraction is just the inverse of addition, we can subtract any value from both sides of an equation to get an equivalent equation. So that's what we did in the second example with the weights here. We subtracted 3 from both sides of the equation, and that gave us an equivalent equation, because 3 plus question mark equals 7 is the same as 3 plus question mark minus 3 equals 7 minus 3. Okay, so I suppose now would be a good time to start getting a little bit more formal and away from discovery mode to a little somewhat formal math with some terminology. So I'm going to give you guys the definition of an equation, because that's what we're talking about here. So an equation is a statement that two expressions have the same value. An equation is a statement that two expressions have the same value. So with an equation like x plus 3 equals 7, we have an expression here, x plus 3, and 7 is also an expression, and the equal sign tells us that both expressions have the same value, just like how a balance scale tells us that these two sides have the same weight. So I can draw more connections between the examples we did with the balance and equations. So the unknown weight we had was the variable. Remember that a variable is used to represent an unknown amount, in this case the weight of the unknown weight. So you see here we used either x or question mark, and that was used to represent the unknown weight. And when we got the unknown weight alone on one side, we called that isolating the variable. Remember, the unknown weight is just a variable. So when we get it alone by itself, whether in the physical world, when we took off those three other disks off the left side and just left it with that on that unknown weight by itself, or whether we took the question mark here and subtracted 3 to get the question mark alone by itself in this equation form, that's called isolating the variable. And when we found out how much the unknown weight weighs, we call that solving the equation. Solving the equation. I've used that a lot. Solving the equation means expressing the unknowns in terms of the knowns. So this equation x plus 3 equals 7, to solve it, we say the unknown x is equal to 4. The unknown in terms of the known. And lastly, it makes no difference whether an expression is on the left or right side of an equation. So x equals 4 and 4 equals x, they're just the same thing. That's the property of equations. That's all I have for this video. We'll talk more about equations in the next video. For now, just remember, what you do to one side of an equation, you must do to the other side.